In this video, we will be talking about the multiple angle formulas. Basically, the multiple angle formulas are divided into two parts. We have the double angle formulas and half angle formulas. So for each of them, we will be giving, we will be having a practice question, at least one, and which will be primarily based on the formula above it. So for the double angle formulas, we basically have three of them. We have for sine 2u, cos 2u, and tangent 2u. For sine 2u, we have it's basically equivalent to 2 sine u cos u. So there's just one variable lying around, and that is the u variable. For cosine 2u, it's basically cos raised to 2u minus sine raised to 2u, which is also equal to 1 minus 2 sine raised to 2u. For tan for tan 2u, it's equal to 2 tan u divided by or over 1 minus tan raised to 2u. And it's also equal to, it's also equal to sine 2u over cos 2u. Now, let's practice. We'll be applying each of the formulas that were recently encountered, that were recently introduced. So, for the practice, sine 2u, let's write the equation first. Let's rewrite it. 2 sine u cos u, which is, by the way, before we even apply the formulas, we are given a part of the unit circle. If you haven't heard about the unit circle, maybe you want to consult the previous videos about it. If I'm not mistaken, it's located in the trigonometric identities video. You might want to check it out. But if you know it now about the unit circle, well, it's good because you won't have to take much more time. So it is specifically stated in the unit circle that a particular sine theta is equivalent to y over r. Therefore, 3 over 5 is y over r, whereas y is 3 and our r is 5. The r variable, is our hypotenuse in a particular triangle. This is our r and x, y, or this could be x and this could be y. So what we have to do now before solving what's required in A, B, and C, we have to solve for x, which is basically the hypotenuse minus the other side, the other given side. So x is basically 4. Now, with x equal to 4, you also have to take note that for our cosine theta, in the unit circle, it's basically x over r, which is 4 over 5. You have to take note of these values. Cos is 4 over 5, sine is 3 over 5. So, back to the formula. Now we have 2 sine u cos u. We can rewrite that as if 2 times y over r times x over r. Whereas our sine is y over r and our cosine is x over r. 2 times y over r. Y over r is 3 over 5, as you can see here. And our x over r is 4 over 5. I'm not sure if your teacher will still allow you to use the calculator here, but the math is pretty easy already. Just solve this and the answer would be 24 over 25. It's a proper fraction. Now, let's move on to letter B, cos 2u. Let's rewrite the formula. Cos 2u is equal to cos raised to 2u minus sine raised to 2u. Let's try to exclude this for now. Let's see if this expression works in our process. So, cos raised to 2u, cos u is x over r, Please remember that. And our y over r is our sine. So we write something like this, and of course substitute the values. 4 over 5 raised to 2 minus 3 over 5 raised to 2. The answer is 7 over 25. Still a proper fraction. For letter C, tangent to u. Basically, for tan to u, it's the compilation. Provided that you've already solved for sine to u and cos to u, you'll divide both of them together in a way as shown here. So sine to u over cos to u. Just substitute the values. So sine to u is 24 over 25, then cos to u is 7 over 25. 24 over 25 times 25 over 7, of course, reciprocate in order to simplify the complex fraction. Cancel like terms. We get 24 over 7. It's an improper fraction. You might also want to take note of those observations. We can't jump into conclusions yet, but I think it's a good start to make conclusions. Maybe, you never know. The answers for sine 2u and cos 2u would usually be proper fractions, and the answer for tan 2u would usually be proper fractions. That hypothesis hasn't been proven yet. However, you may feel free to proceed to answering more exercises in the internet about double angle formulas. Let's move on to the second part of multiple angle formulas, the half angle formulas. This time, we still have three formulas, each concerning sine, cosine, and tangent, the three buttons in our scientific calculator. So sine u over 2 is equal to plus minus the square root. Hopefully I'm saying it right. 1 minus cos u over 2. So just take note of that. Cos u over 2 is equal to plus minus the square root of 1 plus cos u over 2. For tangent u over 2, it's equal to 1 minus cos u over sine u, which is also equal to sine u over 1 plus cos u. I do have a hypothesis. I did observe that based on our previous lesson in trigonometric identities, I suppose it's understandable that sine raised to 2u could be rewritten as 1 minus cos raised to 2u. And based on this formula, sine u is equal to, as per the numerator, sine u is equal to 1 minus cos u. It looks familiar to some extent. Maybe you could just write 1 raised to 2. Maybe the trigonometric identities formula sheet disregarded the raised to 2 supposedly in number 1, since 1 raised to 2 is basically equal to 1. There's nothing surprising about it. Nothing unusual to be concerned about. So this could be a possible observation. Honestly, during my exams, I did thought that because of this formula, this could also be a trigonometric identity, but it hasn't been proven yet. Could not be sure. I couldn't be any sure. I don't know, comparative, sure, I don't know. Anyways, for the practice, if sine u is equal to 3 over 5, provided this specific rule or specification, find the exact value of sine u over 2. Alright, so let's use the unit circle first. Again, sine u or sine theta, whatever that is, it's basically equivalent to y over r. And based on the given, we have a 3 over 5. That makes y equal to 3 and r equal to 5. What are we missing? Our x. So solve for x. The answer is 4. X is 4. Now, to find the exact value of sine u over 2, rewrite the formula to prevent any possible confusion. So plus minus, what do we have? 1 minus cos u over 2. So just substitute the values. Understand that for cosine, it's basically equal to x over r, which is 4 over 5. So in terms of 4 over 5, we can just write 4 over 5 here, then over 2. You're going to need your scientific calculator, especially if your teacher would allow you to use a scientific calculator in your exam. Basically, the answer would be plus minus square root of 10 over 10. The answer could also be, hang on, I'll just box this answer already. Or another answer could be when you press, well, you order the calculator to translate this entire expression into decimal form. What you have is plus minus 0.3162, rounded off to this kind of specification. So what else? I suppose that's it. Let's move on to number 2. If sine u is equal to 3 over 5, there's nothing change. There's no change at all. So I think it's pretty understandable. Don't follow me though. Um, this is just for the sake of the lesson. Try not to do this during your exams. Otherwise, you might take more time when you want to make sure of your answers. I'm just trying to draw conclusions. Since the given of sine theta is, or sine u is 3 over 5, y over r, and when you find x, it's still 4. So to find the exact value of cos u over 2, of course, copy the formula. So if I remember, it's 1 plus cos u over 2. Yes, correct. So let's substitute the values. Our cos u is still the same as what we have here in number 1. Not by coincidence, hopefully. So 1 plus 4 over 5 divided by 2. Put this in the calculator or calculate it manually. Your answer would be plus minus 3 times the square root of 10 over 10. Or the answer could also be in decimal form, plus minus 0.9487. Alright, so let's move to number 3. If sine u is equal to 3 over 5, so we're still given the same. So just copy this anyways. Again, hopefully it's not by coincidence. Then for cosine, it's 4 over 5. Find the exact value of tangent u over 2. For tangent u over 2, the formula, I won't write it anymore. Let's just copy paste. There you go. For tangent u over 2, let's try this. Let's try using that derivation or equivalent of tan u over 2. 1 minus cos u. Cos u is basically this one. Cos u is 4 over 5. Then sine u is 3 over 5. I'll try doing it manually. Oops. I suppose that's a good solution. 1 minus 4 over 5. 5 over 5 minus 4 over 5 is 1 over 5. Destroy the complex fraction. Simplify it. We end up with tan u over 2 is equal to 1 over 3. I'm not sure if you're going to ask this question, but for the sake of everyone who would eventually watch this, I did write my answers without placing, for instance, sine u over 2 is equal to, maybe you could add that part, but I'll leave it to you for now. You can write your answers that way if your teacher prefers it that way, or you can just write it in a more simplified way. Just consult your teacher what suits the best. for the class. So that's it for this video. Let's reiterate. In total, we studied 3 formulas. Both fall down to multiple angle formulas. So that's it for this video. Thank you for watching.